Okay, so let's start then. As I was already introduced, this talk is about new stuff that is going to be included in .NET 5 and also is already included in .NET 3. I was also very nicely introduced already, so maybe I will not spend a lot of time on this slide. I'm a guy related to .NET performance. I really like .NET internals. This book about memory management was translated to Russian because, and with the help of the Russian community, so I believe it's very good. Very thanks about that, because I believe because of that the book is really nice for you also. And as I said, it was maybe mentioned, I don't remember, I'm a co-founder of an initiative which is called DotNetos, which is all about in general performance in .NET internals and other stuff. So if you like such a stuff, look for the DotNetos and you will see another guys also speaking about performance. So the agenda for today is like we have 5 episodes, and if you see that it probably they reminds you something from titles, 5 episodes about various aspects of the upcoming changes and already existing changes in .NET regarding performance in general. So we will just dig into those 5 areas. First of all, the episode number 4, a null hope. So null hope is about nullable reference types, which are already usable because they are added to the .NET Core 3.0. You can use it with the help of CSharp 8, and they are about making reference types that by default are not nullable. Although the name is nullable reference types, in general it means we are turning things around, and now with the help of C# 8 we can make all references non-nullable by default, which is interesting thing because obviously it makes our software safer, because we hope we will get rid of null reference exceptions because of the fact that references are not nulls by default. So we can enable it by turning a flag inside the project settings and set the nullable property to be enabled. The control is much more fine-grained. You have a possibility to turn only annotations or turn only warnings about nullables. We will not dig into that all because we have another topics to cover. What I would like to say just in a few words, that thanks to that now, as I said, references are not null by default, so such a method is safe because you see here we are passing a reference to a customer, and this customer by default now is not null. It shouldn't be null. So this accessing the field name is safe because by default it is not null, and this makes our software safer. Obviously we will have warnings here. For example, if we have a customer with such a field and it is not initialized, we will have a warning that okay, we have a class but this is a non-nullable field, so it should be initialized. So all this is interesting because it seems that maybe it will make our software faster, because obviously checking for nulls would be kind of overhead, and one could think that in general there are some null checks incorporated by the native code generated by JIT, and if we have references not nullable by default, we can expect maybe that the generated code is a little bit faster because now we can get rid of those null checks. So yeah, is it that true or not? Let's imagine we have such a code. As I said, this control is more fine-grained, so you can control some parts of code, whether it has this non-nullability enabled or not. But for us now, the most important thing is the generated code, because this is talk about the performance, not about the nullability and the C# syntax. So from the perspective of the performance, it is the same. Like not having too many words, it is exactly the same, like whether it is disabled or not, whether C# knows that this reference can be null or not. From the JIT perspective, we see that the emitted code is exactly the same. There is no null check inside code generated when we have used the previous approach, and exactly the same code is generated when we are this nullable reference types enabled. So from the perspective of performance, it is exactly the same, and in fact we should not care about it. I mean, it was unfortunately a NoHope, like it is not influencing the performance of code. It doesn't help in getting rid of JIT checks of nullability. It is not how it is working in case of .NET, because if we see this, there is no null check here, and all these null reference types are handled by the accessing the first page of the virtual memory, and this is handled and translated into null reference exception. So in fact, we don't have those null checks. They are handled a little the layer below the runtime itself. So we don't need them, so we don't get rid of them in case of nullability. So unfortunately, it was a NoHope. So the very first episode was fast and simple because I just wanted to say to you that it doesn't improve performance. Obviously, it improves maybe the safety of the code, but not the performance. The second episode, the episode number 5, is about the GC. A lot of various changes that are added or will be added to this GC, because obviously GC and memory management is my beloved topic. So, and this episode will be longer for sure. So the very first thing that I would like to describe you regarding the changes in the .NET GC is the support being added for large pages, which is already merged and already usable because it is already available in .NET Core 3.0. So you can use it on production. And large pages support, if you know something about memory management and how the .NET runtime cooperates with the operating system and how the operating system operates with the hardware, we should probably know that everything that happens with the memory is based on pages, and the page is 4 kilobytes in size. So in the end, for example, when we access something in memory, we need to operate on the whole page. The whole page should be available, and there is a concept of virtual memory, obviously, so the process thinks that it has terabytes of memory, and in the end, obviously, it is backed up by a physical memory, which can be RAM, or maybe it can be a secondary storage like disks. And obviously, not every page will fit into the RAM. Some of the pages are paged to the disk, so from this the name paging comes. And obviously, all this basic building block, which is a page, is happening here. So every time we are paging a memory from RAM to disk, it is based on a page. Every time we access something, and for example, it was on disk, the whole page will be again put into the RAM to access some bytes from this memory region. So all this moving is based on pages. And when the page is 4 kilobytes, now we need to translate somehow what is, we now have a virtual address because programs are obviously operating on virtual addresses, and we need to translate it to a physical address. So how it is going to happen? This is quite costly operation because virtual address consists from some parts, and every part of such a virtual address is just in direction to some level of the page directory that is keeping the whole mapping between the physical pages and the virtual pages. So when we need to translate an address, we need to traverse the tree, which has 4 levels, and this is obviously a cost because accessing memory is tremendously often operation. So in the end, we are tremendously often making this translation, traversing this tree to get the real physical address of this particular page. And obviously this is a cost, so there are some caches because caching is a good solution for many problems. So we have so-called called translation look-aside buffers, which means we are somehow caching the previously made translations, and then it helps us because we don't need to translate some recently used addresses because we have cached responses. So we are caching the previous translations, which helps obviously, but in the situation that you have used terabytes of memory or gigabytes of memory and you are accessing various places of this memory, this caches doesn't help a lot because in fact we are accessing different pages. So every time we really need to translate this address to a physical one, which can be overhead obviously if we are doing and accessing a lot of big memory regions. So for that there is a large page in the operating system. Large page allows you to operate on pages which are not 4 kilobytes but 2 megabytes. So now the number of those translations will be reduced because now the memory is split into 2 megabytes pages in size. So the number of translations is reduced because once we access some very big page, then a lot of addresses will fit inside this page. So this is very convenient and nice optimization. And since .NET Core 3.0 it is enabled, so now with the help of this GC large pages configuration you can enable it, and from now the runtime and the memory management, the GC will start to allocate every page as a large page. So you will have this possibility to reuse large pages. And it was postponed for years because of some internal things inside the GC. I will not cover it here now because it took too much time. But in general, now you can reduce those translations, which is good. There are some problems with that, like some features of that, for example, to run it and to use it, you need to have some special administrative rights. And for example, all pages that are used by the runtime are already committed. So it means there is no this reservation, but we already commit everything. And also such large pages are not pageable. So they will always live in RAM. So you have some performance gain from that also because there is no paging to disk when using large pages, but unfortunately it means you need a lot of RAM to fit your application because they are not paged. So you have this problem. But in general, this is very nice. One of the clients that drive this change was Bing, because Bing is a huge application, web application. It stores a lot of caches. So they had this problem using a huge amount of memory, and Bing is using this flag with the large page support. And as we see, they improved the latency by 20% just because of turning this on. So this is a very nice thing. Obviously, you have all those caveats in mind. It is very nice and easy solution for using big amounts of memory. So this is a nice feature that it's worth to know. Another thing is I recently added is a provisional mode. So the provisional mode is some special fine-tuning which helps GC to make better decisions. And in general, it means that when you are doing the full GC and you see that the fragmentation on generation 2 is very big, you probably would do compacting GC because it is how we would like to fight with fragmentation. But unfortunately, it means that if we have the big fragmentation because of a lot of pinned objects, and those pinned objects are long-living, it means that we will do a lot of compacting full GCs, fighting with fragmentation, but this fragmentation will not gone because it is because of pinned objects. So all those full compacting GCs would be not productive. So this, in such scenario, we will use this provisional mode. There are a set of conditions that enable this mode. So one of them is we have to be in high memory mode, so the system is in general running out of memory. Another condition is that doing the GC, we see that in fact, yes, we are we have big fragmentation of the generation 2, but it would be nice to use this fragmentation, so probably doing only GC1, generation 1, and promoting the objects from generation 1 to generation 2 will help us with fighting with fragmentation better than trying to make compacting GCs all the time. And obviously so we have also this condition of doing a lot of pinning, because this is the reason why we cannot fight with the fragmentation by compacting. And then we enter the provisioning mode, which is just the thing that I described. In the provisioning mode, we are not doing the full GCs which are trying to compact, but we are promoting mostly and doing Gen 1 GCs, which means there will be promoted from Gen 1 to Gen 2, filling the free gaps inside the fragmented generation 2. So it will help in fighting with fragmentation better. And after some time, if we will see that, okay, now the number of pinning is reduced, so now we probably could do the full compacting GC. So this is kind of very nice scenario that helps to fight with fragmentation, especially in the contained scenarios when this Gen 2 is not too big, but we have this fragmentation, so it introduces problem, and doing that helps to make GC more aggressive and better utilize the resources, the limited resources. Another thing regarding GC is GC large object heap threshold. It is also already merged, and we can use it in .NET Core 3.0. So we have this, so I don't know how it is in Russia, but in Poland we have so tremendously popular interview question: what is large object heap, and what is the threshold that makes object being created there? And obviously the answer was for years, since the beginning, 85,000 bytes, but some people, probably also internal Microsoft clients or some important clients, were complaining that the default is too low. For example, they create a lot of big objects and they unfortunately land in large object heap, which treats object differently. As we know, there is no default compacting, can be fragmentation and a lot of allocation there are slower. So it would be nice to have big objects but not being used in large object heap, and we can now do this by increasing large object heap threshold. So this is the thing. We have this configuration setting GC large object heap threshold, and now this can be increased. It cannot be decreased because of the backward compatibility, but it can be increased. So as we have here a simple code which creates a byte array which is big, and because the default threshold is 85,000 bytes, by default it would be created in large object heap. But by setting this flag, now it will, as we see here a proof, will be created in a small object heap in generation 0. So although it is a big object, it will be here handled by small object heap approach algorithms, which can be beneficial if you have this situation using a lot of large objects. Obviously, one could ask in what scenario we can think about using it, and there is no good answer. You need to measure it to see how to tune what is the good number. Obviously, you can use purview, you can use the statistics from the purview session or .NET session, which will allow you to see the fragmentation of the generation 2, for example, and with the profiling API, some tools, including purview, will allow you to see what is being allocated in large object heap, so you will have good knowledge about whether you have this problem or not, and then you have the solution, which is called GC large object heap threshold. So this is a nice and easy thing. Also, you can optimize your applications. Another thing which is even more interesting than the previous ones, because the previous ones were kind of fine-tuning things which are not so fancy, but this one is a big thing. Like, since .NET Core 5, and this is already agreed, we will have pinned and uninitialized arrays. So from the very beginning, the only way to allocate an object was to create to new up it. So we were writing new something and the object was created. But this was by default making the whole allocation working. So there was a contract and there was a guarantee that if we new up something, this will be initialized by 0. The memory will be zeroed. Obviously, this is a little bit differently treated in the large object heap, small object heap. We will come to that. But it was like from the very beginning. And now, since .NET 5 will be introduced, for the very first time, we have a new API for creating objects, which is added to the GC class. And this is only for arrays, because this seems to be the most beneficial first step. So now we have GC allocate array and GC dot allocate initial uninitialized array API, which allows you to create an array, the regular array. As you see, the return an array. So from the color perspective, this is just a regular array. But we have here, obviously, the length, the obvious argument, and we have here the pinned argument, which is a huge thing. And in fact, we have two nice things in those APIs. First of all, we have this allocate uninitialized array, which means from now we will be able to create an array which is not pre-zeroed, which is a huge security issue maybe, because now it will be filled with some garbage after the previous objects. But we probably don't care, because quite a lot we allocate an array just because we need to treat it as a buffer and it will be immediately filled with some data. So we really don't care about what was there before. We just want to have this array working as fast as possible, created as fast as possible. So this is the solution. We can create an array which is not pre-zeroed, which also gives some flexibility for the GC, because now they can be created not only generation 0 when the pre-zeroing was guaranteed, but for example, uninitialized array can be created already in generation 2 because there was a big gap enough to create such an array. So this is a nice optimization. And another very big thing is this pinned flag, which means now we are able to use pinning by default. And as we had small object heap and large object heap, from .NET 5 we will have pinned object heap, which is another completely new type of the heap for objects that are created already pinned. So when you see this flag set to true, it means that this particular object array will be created in pinned heap, and the pinned heap is not moved, so by default objects there are pinned, which is very nice thing, because pinning is a real problem for the GC. It introduces fragmentation. Handling of pinning in terms of compacting is really difficult, so as many objects will be moved to the pinned heap, it is just beneficial for the whole GC and algorithms inside the latency of the GC, because they are a simpler decision to take. So this is very nice, completely new API going to .NET 5. And based on that, because pinned object heap was not designed to contain a lot of objects there, because we don't expect having many pinned objects arrays, probably we could make this even better to reuse pinned array. So we can think about designing something like that, which is already not available, but probably it will be, but you can write it your own pinned array pool, which is an array pool which is operating on the pinned arrays created in the pinned object heap. So every time we run something and there is no already array to be used, we create a new array, but we set that to true, so we are creating this array inside the pinned object heap. So we will be reusing arrays from pinned object heap, so it will be very nice way of utilizing pinned object heap. This API of creating pinned objects has some limitations. Pinned object heap cannot contain objects and containing references and cannot contain references. So we have this quite strong limitation. They only be kind of native unmanaged data there. So we have to check this when we are trying to use this array pool. We need to check whether we want to use it for a type that indeed doesn't contain any references and is not referenced by itself. But this is the limitation. Also put because now Pint object heap doesn't have to be concerned when using marking stage, because GC will not just traverse object from Pint object heap. So this is nice optimization for the GC, which puts this limitation. Unfortunately, we cannot put there objects that contain references. But still, the decision was made because the typical usage of pinning is just to have an array of primitive data to be passed to a native code. So this limitation doesn't bothers no one a lot, because in fact, that's how we use Pint arrays in general. So this is a very nice API coming to .NET 5. One thing what is currently missing is that if we return something to the pool, because obviously that's how our array pool is working, we need to return an array to the pool. And the API is simple. Obviously, we are providing some array to the return method, but this can be a regular array, not the array that we have rented. It can be any array which is not pinned. So it could be quite dangerous, because now we can put into an array pool of pinned arrays an array which is not pinned. So we could, and it would be very nice to have some API that checks whether this array is really an array that is living in Pint object heap, and then only put it inside the array pool. But unfortunately, currently such API is not available. It is considered to be added. .NET team is concerned about the performance overhead of such a check, because it is not trivial. But I would say I hope this API will be added, because of that we can implement safely such an array pool. We will see that. We are here on some very unstable times. And for example, in .NET 5 source codes, if you would like to see, there are already some usages of this API. For example, StringBuilder, as you see, in StringBuilder is just a list of buffers, and those buffers are just buffers of chars. So we will fill it with data. We really don't care about anything what was there before. So instead of newing up new array of chars, we are just now using in .NET 5 in StringBuilder this API to allocate uninitialized array. And as we see, the performance quite significantly can be improved even by twice time if you set a capacity of the StringBuilder and this array is not trivially small. This will really influence the time of the creation of this StringBuilder, because we are getting rid of zeroing memory, which is especially beneficial for big objects, obviously. So this is important and very nice API for low-level stuff. Also, .NET team is really concerned about container scenarios, because containers are getting more and more popular. So we have container scenarios covered by .NET team also. And there are some things that they are really trying to fine-tune with success to make .NET and memory management by the GC more aggressive, and using the limited resources in a Docker more let's say, better simply. And a lot of changes is added here. One of it is just this new configuration flags that you can set for a .NET application, which will just allow you to set a hard limit of the memory usage, because there were some problems, and before .NET Core 3.0 there were some issues that when you set a limit of memory usage on the Docker on the Docker instance, those limits were not truly and fully understood by the .NET runtime. And instead of really trying to understand those limits, we can use a hard limit. With the help of GCHape hard limit configuration, we can specify a hard limit for the GC, which means the GC will not make bigger memory usage than this hard limit that was set. There is a hard limit % also, but typically we will use the JC hard limit, simply saying, for example, that this instance of this application should not use more than, for example, 500 megabytes. And this is a hard limit for the managed heaps maintained by the GC. So it is just that. I mean, there is no any place for misinterpretation. This is just the limit. Additionally, as I said, there are some another high tunings. So, for example, specifically for huge machines that contain many CPUs, there is a set of minimum size segment to make better utilization of the memory. Those are some fine tunings that are important, are not controlled by you because they are just working out of the box. So in general, they are just there. You cannot disable them. And there is a set of such changes, like, for example, algorithms has been improved to make GC more aggressive and taking into consideration those limits in more paths. Like, for example, this check is now included in when you are committing some memory in the allocator, and so on and so on. When we are reserving also, we are just getting more, GC is more and more concerned about those limits. And what is really interesting here is that, as you know, probably large object heap is not compact by default. And this was by design from the very beginning of the .NET runtime, because large object heap can be quite big, because compacting it is just designed for having not too many objects. And so we probably would be afraid of moving a lot of large objects, because it obviously introduced a huge memory overhead to move around objects, big objects inside large object heap. But there is a difference if you have a huge application running on the machine utilizing dozens of gigabytes. So your large object heap, for example, can be of size 16 of gigabytes, which means we have a huge amount of memory to compact. And the different scenario is when we are using container and we have put some limits there. So probably we now are saying about gigabytes or just hundred of megabytes of the size of large object heap. So now maybe to make GC more aggressive in such limited scenario, it is wise to make this compacting enabled. So in container scenario, if there is this memory limit set, large object heap can be compacted automatically. For the very first time in .NET, they can be compacted automatically, because now we are not so afraid of moving objects, because we expect this large object heap is not so big. And the time that this compacting will take is not so big. But as we see from the measurements that I done, even compacting 1 gigabyte can take almost 1 second. So it is a huge pause introduced by the GC. But if the size of the surveyed space is in hundreds of megabytes, we are talking now about some milliseconds, few dozens of milliseconds. So it is much safer now to compact and make GC more aggressive in container scenarios, because we are really concerned about reducing memory usage in a container scenarios. So this is another nice optimization. Regarding what's already added to .NET, we have also a huge topic of diagnostics, because for years it was a kind of problem, especially on Linux. We were just left behind, and there was no any good support of diagnostic, especially on Linux, but also on Windows, what was limited. So since .NET Core 3.x, we have at least eventually good support of some diagnostics, and there is the set of tools which are in general called diagnostic tools command CLI simply, and it is a set of command line tools that are just for you. You can install them as a global tools, and there is the set of those tools. Like, for example, it is a tool for making a memory dumps, some analysis of memory, or doing a trace that will allow you to profile the CPU, profiling simply. So this is a set of tools that are added, and they are really nice. There are at least eventually we have something like that. So for example, counters is a very nice tool which allows you to be a replacement for performance counters, because if you had used .NET on Windows for many years, we were using performance counters as a very low overhead of observing .NET processes in terms of memory usage, logs, everything in fact can be observed by the performance counters introduced emitted by .NET runtime, but unfortunately .NET Core does not support performance counters even on Windows. There are some ongoing discussions whether we would like to revert that and emit performance counters on Windows, but as far as I know it will not happen. So we will now moving from performance counters to counters emitted by the runtime with the help of event pipes and other diagnostics internal stuff. So those counters are very useful for getting a very low overhead information about what is the health of the process. So we are simply using .NET counters. We are saying monitor a given ID, process ID, and you will have a set of informations. Those informations are getting more. We are getting more and more informations, like informations about the GCs, the utilization of the memory, how often GCs happens, where are the pauses introduced, and what is the CPU usage, and also some information about the thread pool inside. For example, what is the completion rate of work items on the thread pool. So we can get quite nice overview of the process. Currently, obviously, this set of information is limited, so there is only currently there are maybe 20 counters available. Like in .NET we have hundreds of them, so obviously there is still this difference, but at least we have something that we can use. Here also with the diagnostic tools we can make a memory dumps, both on Windows and Linux. There are full memory dumps that it could be done previously, but if we ever try to do that and analyze memory dump, especially on Linux, it was really painful to do that. So now diagnostic tools allows you to make a dump. So we are just saying, okay, I want to dump the memory of a given .NET process, and moreover, which is even much more powerful capability, is that you have analyze tool which you can say .NET dump analyze the given dump, and then you have this whole API of so-called SOS extension. So you have ever used WinDBG before. This is exactly this. It allows you to analyze memory dumps both on Windows, Linux, and as far as I know also on Mac OS, but I'm not sure. This is very nice, convenient thing. GC dump also another thing that you can be interested is about making very low overhead statistical information about the GC and references between objects. It is turning on the special mode during the GC that tracks all the references, and it allows you to generate very convenient small file that describes not the data itself but the references between objects. So it is very nice for doing analysis. For example, with the help of the purview, you will see what is kept in memory by what. So the very nice thing. And additionally, very recently, like 1 month ago, all this also is available from CSharp, because there is a NuGet package for the Diagnostic.NET Core client, and it allows you to make all those analyses also from the CSharp. So now you can enable a session that will observe some events, counters, and based on that you can generate things like send them to the monitoring tool or anything. So it is also available from the programmatical point of view. You can automate things, so it is very nice. And there are some also very low level stuff that I will not cover now because we have a limited time. If you are interested in a profiling API, the .NET team has added new 2 levels of profiling, very lightweight profiling, which allows you to get information about the GC, which is nice, and also some medium weight profiling, which allows to track references between objects. So they will be used by profilers at some time in the future, I believe, because they will introduce some very nice diagnostic capabilities with small overhead. But this is very low level stuff for another session, so let's move on. What is much more nice to use is an upcoming API which is called GetGCInfo, which provides rich data about the GCs with very low overhead, because in fact they are just getting information that is inside .NET runtime already, and it is just exposed. And such a call, GetGC memory info, will provide you an information about the last GC that happened. You can filter it here, as you see, so you can be interested only in ephemeral GCs like Gen 0, Gen 1 GCs, or you can be interested in full blocking GCs. It is just filtering, but the most important here is what is this API returning, and this is quite rich set of data, as I said. So we will have, for example, information about every generation, and for the very first time in such a convenient way, we have an API for seeing, for example, what was the fragmentation before the GC and what is the fragmentation after the GC, or for example, what was the size before the GC and after the GC. So a lot of very nice information. Also the pause introduced by the particular generations, that's very interesting information. Some statistical data, like what is some maybe more diagnostic data, like whether it was compacting or concurrent GC. So now you have very nice API exposed to track information about the previous GC, so you can somehow utilize it and emit, for example, again to a diagnostic monitoring tool. Then we have some interesting API that was planned to add, but as far as I know, it will be not add. We will see. It depends really on the client. So if you like to see this API, just contact Maoni and say, I really want to have such an API. This is an API that will track the whole object graph, which is kept by a given object, to get the size of it. So starting from a given object, you would be able to calculate what is the total size of all objects that are kept alive by this particular object, which can be useful, especially imagine that you are writing your own caching mechanism. You have a cache entry and you want to trim cache, but you want to know what will be the size of memory that will be retained if I get rid of this particular cache item. And this would be a very nice API for using such algorithms. So maybe it will be added. We will see in future. Unfortunately, for now, as far as I know, the design of it is postponed. And there are also another things that should be added and are already added, little fine-tunings of the GC algorithms. Those slides will be available, so you can follow the links that I'm providing here. I will not go into such a deep things because we are just don't have so many time here. But some work is being done to make GC, to reduce the latency of the GC, especially doing some fine tunings, how the internals are working of the GC. So those were the general things that are ongoing in the GC, and they are improving there a lot of things. The most significant change for me is this Pint object heap and creation of uninitialized arrays. Another thing that we have in .NET Core is the return of app domains in the form of assembly load contexts. So app domains are missing in .NET Core. They were used in the regular .NET framework for many things, like, for example, for unloading plugins, for assembly loading isolation. But unfortunately, they were also used to make some security between assemblies, but it was not very good because there in fact no guarantee from the runtime that it provides any security. It was just a kind of misconception and bad perception, misuse of subdomains. And .NET team decided to remove them, especially that the code of subdomains was very complex and it doesn't provide this security boundary. So instead of subdomains, in case of .NET Core, we have assembly load context, which is just a lightweight version of it, which is just for isolation of loaded assemblies with the powerful capability of unloading it. So we can load an assembly inside such an assembly load context, and then we can unload it. So it helps us to make this plugins architecture. Anything that needs to generate code, use it for some time, and then we don't need it anymore. So this is very nice capability for unloading. What is interesting here is that this unloading is cooperative. So we can call, for example, we cannot call, in fact, this directly. When we stop to use objects and we get rid of this particular assembly loaded into assembly load context, GC will start to reclaim objects from them. So that's the cooperative approach. Again, this is maybe not so important from performance perspective, but very nice from the memory management perspective. You have now this capability of dynamic assemblies being loaded and unloaded, but it also can introduce you a memory leak, because even a single object being alive from such an assembly will prevent unloading the whole assembly. So we should be really careful about the unloading part, but we have at least this capability, which is nice. Another much more performance-related thing is all the things related to the JIT, because it has quite significant improvements in terms of performance. So there is obviously tired compilation that you know about it probably, and now the JIT has the possibility to have multiple levels of generating code. So we have tier 0, which is sometimes called Quickjet, which uses minimal optimizations just to generate the code as fast as possible. And after some time, the regular normal optimizing JIT will re-JIT the same method and start to use this optimized version. So it is a nice approach, which is also popular in JVM hotspot for many years. And that's nice optimizations that can be enabled. So you will have this possibility to have the method with a slow version, but it was generated very fast. And after some time, currently it is like 30 times calls of this particular method, it will be re-JITed to a new version. And regarding that, it is a very powerful and mind-blowing feature planning to be added to .NET 5. It is not decided yet whether it will be added or not, but it is called OnStack Replacement. And it means that we will be able to re-JIT method while this method is executed. We have active stack frames of a particular method, but we will be able to re-JIT it to an optimized version, which is just mind-blowing, because we will just have a situation that we started to execute a method in a slow version produced by the Quickjet, and then it will be re-JITed to an optimized version, and out of a sudden it will start to work as this optimized version. That's why it is called OnStack Replacement. We are saying here about OnStack Replacement of the method being optimized. There is a very interesting design document about that you can follow. We have here a set of decisions, how it is working. For example, what are the touch points where that transition can happen between optimized version and the optimized. Currently, it was decided it will be under loops. When the loop is just making a back jump, there is a decision here. We could change it because mostly it is useful for methods that have a huge loops, and they just needed to be optimized. We don't leave the method is executing a loop many times. So here it is a good point to, okay, let's optimize this method because it has this loop being executed many times. And that's a very powerful thing. Every such a patch point tracks the counter, and if we hit it enough many times, we will start to rejitting in background, and when this rejitting is done, we will just replace and we will make this transition to a new optimized version, which is a powerful thing. There are some interesting caveats regarding that. For example, when we create this new optimized version, in fact, we need to create a new stack frame for this new optimized version, but we cannot get rid of the previous one because there can be some objects like local alloc objects or anything which was local for this particular frame, and we get an address of it, so we cannot get rid of this object because someone is using address of it. So this optimized version in fact will use the new stack frame and incorporate the old one inside, so we have kind of two stack frames because we need the old data there. But that's some interesting caveats that people are just fighting with when designing such things. So when we have kind of method here that has this loop inside, typically the optimized version will be very consistent, will contain only some comparison jumps. This will be the code generated by the regular JIT. The optimized one. The not optimized one would be much bigger because obviously this is the JIT which was not optimizing, so we have here a lot of redundant checks. We are using stack here. This is not optimized, and that's okay because it was quick JITted. And this is a version without OnStack replacement. And when we enable OnStack replacement, we will see that indeed inside such a method there are those patch points included. So inside the method is interleaved with the calls to the patch point in counters. So every time this loop will come back, in fact we are increasing this patch point, and if this patch point is above some counter, in fact we are now down counting. So when it is a 0, we will call a patch point method which will start doing all this triggering to a optimized version. So it is kind of mind-blowing technology that will be added to .NET 5 or maybe some future versions that will allow to do such a magic and replace a method and optimize it during execution. Another thing is escape analysis that is already added also. So you have this possibility to use reference types that we know that they do not escape a particular method. So like here, we have a class that has some fields, it has some method, and we have a method which is using this class, but this class and instance of this class does not escape this method. So in fact, there is no sense in creating it on the heap because no one else is using it, so it could be created on stack. And this is exactly what escape analysis is doing. Instead of creating this on the heap, calling the whole allocator and all these troubles because of using a reference type instance, the escape analysis will see on the JIT level that okay, this is enough for this particular method to use it on the stack. So with escape analysis, the code is significantly reduced. We get rid of the allocation totally. We get rid of the whole overhead of the GC, which is very also powerful thing. And I believe it will speed up some programs really significantly. Currently, there is a simplified version of escape analysis implemented. There is a set of limitations what will block stack allocation of reference type. So as we see, we cannot stack alloc strings, arrays. The class cannot have GC fields, so references. There is a set of those limitations because currently we have this limited, let's say, simplified algorithm being used. But that's fine. That's the first step. Also mind-blowing from my side. And the last thing is the episode about some various interesting high-performance, low-level APIs being added to .NET. So first thing that I would like to describe is unmanaged callers only attribute that is already added to .NET 5. It will be added, but it is merged, so it will be available since the .NET 5 premiere, which means that a method can be marked with such attribute, and it means that this particular method can be directly called from the native code, and then you can use the address of operator on a C-sharp method and pass it as a delegate, for example, for native code. So it is very convenient attribute that allows you to use C-sharp code from unmanaged code. Obviously, here I'm also using function pointers, which will be added to C-sharp 5. So having static method, which is just doing some very simple stuff here, I can take an address of it. This is a new type that was designed for function pointers, and I could pass this callback as a pointer to a native code, and then it could be used and called from inside. So this is interesting. Obviously, this also can used as kind of introducing DLL export attribute, because having those methods built on that, we could create a library that is just exporting methods for a native code, which is also very nice. And there are a set of restrictions what a method can have this attribute. So first of all, the method must be static, and this attribute makes prohibited to call this method from managed code. It can be called only from unmanaged code, which is also powerful thing that makes your code organized a little better. Underneath, it is not a magic. It is still using painvoke and reverse painvoke frames, so it is just more convenient way of exporting your methods. For example, currently you could use this method Marshall get function pointer for delegate, which is kind of the same thing, but then now it is statically available in the C-sharp level, on the level of the C-sharp syntax, not by using such a Marshall.method. So that's nice. Another thing is the suppress GC transition, also already merged into .NET 5, so it will be available from the very beginning, is when you call a painvoke method. So you have a C-sharp code and you are painvoking some imported unmanaged code, so now we are talking about the different direction. The huge amount of things happen, because in fact, when one of the things that is happening is switching from so-called cooperative GC to so-called preemptive GC. Cooperative GC is the one that is just the managed code, and we probably need to convert to switch to a preemptive GC. And as we see from the bulk of the runtime, when the painvoke is made, a huge amount of step is there, and only in the very middle there is a real painvoke. So we have quite a lot of overheads because of building frames around this and making this transition between GC modes. And now, since .NET 5, we will have this possibility to conditionally remove this transition. So when you have some unmanaged method and you want to call it by importing from C# with the help of painvoke, you can set this attribute saying suppress this GC transition, and from now we will not have this GC switched, which makes this transition and this painvoke reach really faster. There is no overhead of handling this scenario. So this is for making painvoke faster simply, and because painvoke is called tremendously often in low-level libraries, this can be really beneficial. And obviously be careful, because this makes blocking GC, because when there is a thread which is in a preemptive mode, and because we stay in a cooperative mode. So in fact we are staying in cooperating mode, but now we are executing unmanaged code which is not cooperative, which means if this code is executing for a long time, we will block starting GC, because our unmanaged code which is in cooperative mode will block it. So it is dangerous. That's for sure dangerous. And the very last thing, because we are running out of time, is the new API for StringBuilder. StringBuilder so far exposed this very sad method. We were filling the data inside the buffers of the StringBuilder with the help of append method, but then at the end we really need to initialize a string, create a string with allocate a string, which was a set, because probably we would like to avoid allocating strings here. And there is now this new API which is called GetChunks, which allows you to iterate through every internal buffer inside StringBuilder. And as we see, it returns read-only memory, so without allocations we are having now access to the particular buffers inside StringBuilder. So we can utilize the buffers from StringBuilder without allocating them and converting them to string, which is nice. We can see examples of that, like if another API accepts span or read-only memory, you can use them in chunks and write in chunks. You don't need this temporary string to be passed somewhere else. If you have an API that allows you to utilize span, this is an example from TextWriter, which is doing exactly that. And there is no string here. We are just getting chunks from StringBuilder and using it, passing it somewhere else to write to somewhere. So this was kind of very, very fast iteration through various things added to .NET. There are obviously high-level important things being added, like gRPC, faster JSON, much faster regex parsing. So all this stuff is the topic for yet another talk. I will not cover those. I was more concerned about more low-level stuff, like the whole .next I love, because it is concerned about low-level stuff. And if you would like to track some such things, there is a very nice recently added .NET 5 runtime epics GitHub page. This link will be provided by slides. So there is the .NET team started to track epics, which are just big projects regarding improvements in .NET, and many of them are related to performance, reducing latency. So if you are interested in those topics and you would like to keep track of the ongoing work, this is a perfect link that at least tracks those most important big projects regarding this. And in general, that was all that I would like to show to you today. That's all. Thank you for listening, because it was quite fast. I hope you have learned something. So I believe now it is a good question. If there are any questions.
Thank you very much, Konrad. It was very, very interesting talk, and I'm feeling my brain is going bigger and bigger. I'm filling my brain by knowledge about .NET Core 3.0 and 5. Well, we have a questions.
Awesome.
First questions is about application domains. If we have no application domains, what for we have appdomain class and a part of its functionality, such as appdomain current domain or appdomain create domain?
Yes, they are just, this is the strange API when we have assembly load context by those old APIs about appdomains is not supported. So in fact, we should forget about appdomains. Let's just concentrate on assembly load context. They are not for appdomains separation, but more for loading assemblies in different contexts. So these old APIs probably should be just forget.
But what will happen if one will call, for example, appdomain create domain or some?
As far as I know, there is a throw of not implemented exception.
Okay. Don't you know how assembly load contexts are dividing or isolating assemblies inside the memory?
That's kind of from the memory perspective, assembly is kind of metadata description, but from the perspective of the objects, they are indeed quite living next to each other. So there is no real separation in case of memory usage. GC treats them as a bunch of objects now referenced by a new metadata objects, let's say internal arrays of tracking some statics, for example, and other stuff. But from the perspective of memory usage, I would like better to describe it as just the same bag of objects. Only .NET Runtime knows that this is from this assembly and this is from that assembly load context, but we should not treat them as in any way separated in memory. They can even interleave. If the GC is compacting, they can interleave. This is only the difference on the what can be accessed, because GC and the .NET Runtime knows what belongs to a particular assembly load context.
Okay. What about provisional mode? How we can enable it, or is it a switchable feature, or is it by default and we can't switch it?
By default, it is enabled, and as far as I know, it cannot be disabled. At least I'm not aware, but I'm not 100% sure. So maybe you can disable it, but it is enabled by default.
Okay. And what is your, favorite feature from all of these?
My favorite is regarding gc.allocate array and allocate initialized array, because it is something really new coming to .NET Memory Management, this possibility to create array that is initialized and that is already pinned. But this is from the practical side, and from the mind-blowing side, for sure, is this OnStack replacement. Like, this is really complex thing to do, really unsafe thing to do, in fact. So I don't believe they will manage to add it even to .NET 5. Maybe in kind of opt-in experimental mode that you can enable it, but it will be disabled by default, because it is so complex things to do. And they are just starting with experimenting with that. They are even considering another things, like, for example, deferred execution, because if you have OnStack replacement, they can also use it for different features. Like, for example, JIT will be able to JIT only parts of method, and because it expects that this and this part will be needed, and only if it happens that unfortunately the different part was needed, it will be rejected additionally, because now we have OnStack replacement, so we can JIT only parts and JIT in advance and JIT only lazily JIT in case there is some different parts of methods are necessary. So those two features, one which is currently available and is very nice, and this mind-blowing one which is just really hats off for everyone involved in implementing it.
Okay, we have one more question about assembly loading. Can we use objects from different assemblies? Their classes have the same namespaces and name. How it will work if their properties are different?
That's interesting question. So you're saying that you are loading two assemblies, but they have different properties, but the same name, like there is a version difference between
namespace, name.
Yeah. That's interesting question. For now, I don't know. Like, these good things to experiment with. Unfortunately, I don't know.
Okay, and to research it a little bit.
Yeah. And write a good blog post.
Well, one more question. How do you think, in general, .NET is going into the right direction or not? What all Microsoft is doing with performance in .NET?
I believe the direction is good. I may be sometimes a little concerned about the speed of those changes. Like recently we added escape analysis, which is all maybe not even already well tested, and currently we are concerning OnStack Replacement. We have multi-tiered JIT. So from the internals of the runtime, the speed of changes is quite significant. But I trust .NET team. I believe they will not release anything which is really good tested. So let's say that this is concern, but not so big. And the different part of it is the whole changes upcoming to C#. And this C# is started to be huge language with huge number of possibilities. Even now what was added, but now we will be added in C#9, we will have function pointers, we will have a lot of different things, and this language is becoming, I would not say too big, but containing a lot of features. So when I was starting C#, it was quite easy language with generics, and we had some stuff there. But now when I would start learning C#, I would be, I don't know, it is hard probably, but I'm not sure whether it is bad or not. I mean, I'm seeing a lot of discussions about that. Some people are saying it is bad and it becomes too polluted language with too many APIs. On the other hand, someone would say that, okay, but you don't have to use them. They are there, but you don't have to use them. So what's the problem? But another guy will say that, okay, but maybe someone will use them, so I need to understand them because other people in the team are using this. So there are various aspects of that. I'm personally happy with that. I'm happy that that C# is becoming multi-level language, so you can write high-level stuff, but you have also very powerful low-level capabilities. So the short answer for me, it is fine, but I really understand concerns and the general discussion about that.
I think it's difficult now to become even a junior in C# with such a huge amount of features. Okay.
Yes, even the property,
next question.
Even if you have a property thing, now you can create properties in so many ways that you can use lambda, expression bodies. Then you have now this init. Yeah, sorry for interrupting.
No, it's okay. Next question is about OnStack replacement feature and the escape analysis. Are there some libraries that allow to do hot patching or JIT methods by replacing the JIT body with other code? Do you think hot patching will still be possible?
It is possible, but I don't know any library. There is no brave enough guy, developer in the world that introduced that. So I don't know the library for sure. There is for example, there is a great post from Alexander Mutel, which created a managed JIT. So he replaced the JIT to the one which is written in C#, and this is a very good starting point for understanding how you can do such things. But I don't know any library around that, unfortunately.
The author of the question is giving us an answer that there are an Harmony library, Harmony lib.
Oh.
Which can...
Okay, I will look at that. Thanks.
Okay. Well, guys, I think we have a small time.
Okay.
Yes.
Well, thank you, guys. It was really interesting for me. New features, such pretty low-level features in C#. It will be, well, at least very interesting. I don't know how wide are we going to use them, but still, well, thank you very much, Konrad. Thank you, Yuri.